Today in class we covered even and odd functions and introduced piecewise functions. For determining if it's even or odd, you first plug in negative x and then simplify. If all signs change after you simplify, it's odd. If all signs stay the same, it is even. And lastly, there's a chance it's a mix. If some signs change, neither. So 3 ways this can play out: odd, even, or neither. And we're going to plug negative x in and see what happens. So I plug in negative x here. And make sure you use parentheses. And I get negative x squared, which is negative x times negative x, which is just positive x squared. And look at what I typed and what I got. No change, right? So that is, let's call these scenarios. That is the second scenario. Sign stayed the same. It's even. Let's try it for g of x. Plug in negative x. Careful with those parentheses and exponents. And there's this rule: when you have an even exponent, it's going to be positive, because negative x times negative x is positive, times negative x is negative, but then times negative x becomes positive. So positive x to the 4th. And we already did that far right one right here. We did that on part A. So this negative 2 stays, but that negative x became positive x squared. So those signs look the same as what I typed. So even again. All right, let's try h. Plug in negative x. You're probably getting the rhythm with this. You maybe see the pattern and already know what we're going to say. Negative x squared, negative x plus 1. Looks like we're going to have a mixture, right? Negative x times 2 is negative 2x and plus 1. That middle term flipped to a negative, but the first and the third stayed, so this one is neither. And we need an example for an odd, so let's give ourselves a part D. Let's call this J. Let's say x cubed minus x.
Would the owner...
So I plug in negative x. This time I have an odd exponent. So there's nothing to really cancel out the negative with. I mean, it cancels out at first. Negative x times negative x times negative x. It becomes positive, but then it becomes negative, so negative x cubed. And then negative negative x becomes positive x. All signs flipped. We have an odd function. All right, let's try another type of problem. This is an introduction to piecewise functions, and this one's a word problem. So it's called piecewise if ever the function is dependent on the value of that independent variable. So in this one, t, or time. And it's kind of an interesting problem. It deals with history, early 1900s immigration. A huge amount of people were immigrating. 15% of the population were foreign born in 1910. So they made two functions based on what span of years we're looking at. So 1910 to 1970, we're looking at that first. And 1970 to 2000, we're looking at the second function. On part A, by them writing that, they're really saying let t equal 30, which 30 is between those two numbers, right? So I want to use the first function. So maybe make that note to yourself if you need to. Use first equation because 30 is between 0 and 60. All right, let's plug in 30. I have negative 11/60 times 30 plus 15. So I'm going to multiply on my calculator. Negative 11 times 30, divide 60, add 15, and I get 9.5. Some people are struggling with the word problem part. That's a percentage. And it's also a giveaway over here in the where they typed. Let me change colors so y'all can see this writing. That's a percentage. And they use the letter P right there for percentage. So what I just got was a percentage. So 9.5% in the year 1940. Why 1940? Because 30 plus 1910 equals 1940. Look right up here. 1910 is the beginning. All right, let's try B. I'm going to plug in 80, and I'm going to use the second function because 80 is between 60 and 90. So I have 1/5 times 80 minus 8. 80 divided by 5 is 16. Subtract 8, and I get 8%. And that's in the year 1990. Because 1910 plus 80 is 1990. Hope that made sense. See y'all later.